Hello everyone, Mrs. Belo here. In this video I'm going to be going over slides 11 through 22 in your chapter 2 notes, which will involve scientific measurements. Two things that we're going to be focusing on a lot are significant figures and scientific notation. But before we get to that, I want to talk a little bit about percent error. This is something that you're going to be using a lot in labs. So percent error is the accuracy of an individual's experimental value compared to the actual accepted value. So when you are carrying out a lab, let's say you're looking for some value that you already know. For example, in chapter 11, which is not until next semester, you'll do a lab where you're looking for something called R. And R is 0.0821. And you do a lab where you try to carry out an experiment and then you calculate this value using your experimental results. So this would be the accepted value, which gets plugged in to this part of the equation. While your experimental value, this is whatever you did in the lab setting, would get plugged in here. So it's the experimental value minus the accepted value divided by the accepted value and then times 100. Note though, this value here, you are subtracting, but you want to take the absolute value of it. Again, this is something that you're going to be doing in lab, and typically you want this to be low. Okay, you want to have a low percent error. That means that you did a really good job in your lab and you got really close to the accepted value. Typically, I would say usually like at least under 5%, generally speaking, would be pretty good. Next, I'm going to talk about significant figures, or sometimes we call these sig figs. So these are the digits known with certainty plus or minus a digit with uncertainty. So it's how accurate are your measurements, like how accurate can you be, okay? So when you were doing measurements like these, okay, in the classroom, even here in your notes, there's only so much accuracy that we can go to, okay? So that's where we're going to talk about sig figs and how to count them, which ultimately will help you with writing them. So here's kind of the rules for significant figures and a few examples, okay? So you can read over these, okay? I'm not going to go through these just because it's very repetitive. Rather, I'm going to show you a tool for how to figure out how many sig figs you have. That's a nifty way to remember them. So if you're thinking about the United States being right here, Atlantic is on this side, the East Coast. Pacific is on the West Coast. So when you're looking at one of these significant figures, you want to ask yourself, is the decimal present or absent? Okay. So for example, this one, it is absent. I don't see a decimal. So if it's absent, that means you would start on the right side of the number. And you're going to move towards that number like you're moving towards the US. And the first non-zero number you come across, you're going to count that and everything that comes after it as significant. So if I'm looking at this number here and I start, I'm going this way because I'm approaching from the Atlantic side, the first non-zero number I come across is going to be 1. So I would start counting the sig figs from here and everything that comes after that. So I would have 1, 2, 3, 4, 5, 6 significant figures. versus this example right here. It has a decimal. So I would start from the Pacific side, and as I'm approaching, I'm going to, again, only start counting when I get to the first non-zero number, which in this case is 7, and I'm going to count everything after that as significant. So in this case, I only have one significant figure. So let me do some more examples with you. Okay. So I'm going to do the first 2 examples with you, and then I would like you to try these ones on your own, and then the next day we're going to go over them in class. Okay. I'll leave that right here on own, and we'll go over those in class. So number 1, is the decimal present or absent? Okay, so I'm going to make a note to myself over here. I'm going to say that it's absent. So we're going to start on the right-hand side of the number, or the Atlantic side. If you imagine this is the United States, this would be the Atlantic side of the United States. And then I'm going to move towards the number, towards the United States. And the first non-zero number that I come across, I'm going to count as significant. So that's going to be 4. So I'm going to start here. I'm going to start counting 4 and everything that comes after that as significant. Again, 4 is a non-zero. It's not 0. Okay, so that's why I'm going to count it. So I have 1, 2, 3, 4. So that means that this number has 4 significant figures. Let's do another example with the decimal being present. Okay, so in number 2, I can see that the decimal is present. So that means I'm going to start on the Pacific side of the number, or the United States, if you will. And I'm going to move then towards the number, or the United States. And the first non-zero number, so a number that's not 0, so I'm going to skip all these that I get to, I'm going to count as significant, and everything else after that as significant. So I'm starting here at the 2 and the 3. I'm going to count both of those numbers as significant. So this would have 2 significant figures. Okay, leave my notes here. So go ahead and try these 3 on your own, and then we'll go over them in class the next day. So besides using significant figures, especially in lab and when you're doing calculations, another important thing to know is scientific notation, which you may or may not have seen before. So this is when you're dealing with really, really big numbers or really, really small numbers. So numbers are written in this format here. So M is a number that is greater than 1, but less than 10. So it's going to be somewhere, it's going to be a number that's between 1 and 10, or 1 and 9, excuse me. So it's a number between 1 and 9, okay? And it can be decimals. For example, in this problem, I have 6.022. That's a number between 1 and 9. So that's what that M value is. And then it's going to be times 10 to the nth power. So the n is going to be some type of a whole number, and it can be positive or it can be negative, okay? That's this exponent here. That's that n number that I'm talking about, okay? And then the coefficient we can call, that's the m value. So when that number is positive, it's a really big number, and when it's negative, it's going to be a really small number. And also I did point out that this would have 4 significant figures because the decimal is present. So I'd start from this side, and I start counting the first non-zero I come across, which is 6, and everything else after that as being significant. That's why this has 4 significant figures. So this is something that will come up when you're doing maybe calculations and you're getting a really big or really small number. You have to know how to write in this format, and also how to go back and forth between this format and then standard notation, which is how we normally write numbers. Okay, so here's some examples. So if I have, like you saw up here, this exponent, that n value was a positive number, okay? So that's for really, really, really big numbers. So large numbers will have a positive exponent, okay? And here's another example right here. So if I had 65,000 kilograms and I wanted to kind of shorthand that, this is another way to write that number. It still means the same thing, okay? It's 6.5 times 10 to the 4th kilograms. These two are equivalent to each other. It's just a different way to write a number. So you're not writing out all those zeros. Versus if you're dealing with really small numbers, so let's say 0.0078, that exponent is going to be negative. Okay, so when you're dealing with really, really small numbers. And I will explain the moving the decimal to the left and to the right when I do the examples on the next spot, or on the next slide, excuse me. And again, I'm going to explain this rule as well on the next slide with the examples. We're going to move the decimal until there's one digit to its left, meaning that we have a number between 1 and 9, so it can be written as a decimal. So for example, these ones here, I have 6.5 and 7.8. That's the format that we want to write in that's correct. And then the places that we're going to move, how many decimal places we're moving, is going to tell us our exponent. So this might kind of remind you of when we did those metric conversions with moving the decimal, okay? Kind of the same idea, but we're just writing in a different format. Okay. So I'm going to do numbers 1 and 3, and then I'm going to have you do 2 and 4 on your own. And then again, we'll go over them in class the next day. Okay. So I'm going to go over number 1 here. So technically my decimal is here right now. This is a really big number. So I'm going to move my decimal until I only have one number to the left of the decimal. So again, it's going to be a number between 1 and 9. So let's go ahead and do that. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I moved it 9 spaces. Okay. And now I put the decimal there. So I have the number 2, so only one number to the left of the decimal. And again, that's a number between 1 and 9. And then 0.3. Okay, and we can leave it like that. You don't have to write all those zeros. Instead, you're going to say times 10, and then how many spaces you moved it. So we moved it 9 spaces to the 9th power. And this actually would make a lot of sense in my calculator, okay? If I were able to go back and forth between those notations. So if I did 2, 3, 0, 0, 1, 2, 3, 1, 2, 3, enter, okay? There's the number in its normal notation. Now if I do 2.3, and I'll show you how to do this in the next video, e to the 9th power, that's still going to give me the same answer, okay? So those are equivalent to each other. This is just a little bit easier to write than all those zeros. So now let's do, oh, excuse me, I'm going to have you guys do 1 and 3 on your own. I'm going to go ahead and do number 4 for you as an example. So now this time, in this example, I was moving the decimal to the left, okay, because we were dealing with a really big number. Now I'm dealing with a really small number in number 4. So notice my decimal is here. So again, I'm going to move it until I only have one number to the left of the decimal. In this case, we have 5, which is again a number between 1 and 9. And this time, notice I moved it to the right. Okay, so I moved it 2 spaces to the right. So I have 5.1 times 10 to the negative second because I moved it to the right. So 5.1. So if I put this in my calculator, I would actually get the same value, 0.051. So do 2 and 3 on your own, and in the next video, I'll explain the stuff in the calculator.